Good morning, ladies and gentlemen. It's 10:30. Thank you, Judy. It's 10:30 and we're making a start. This is the last day, as you know, of Victam, and it's really important that you, all our listeners out here, all our attendees, have an opportunity to spend time in the hall. So I'm asking my speakers to be briefer, and we can get through these 4 presentations in a timely way. Right, my name is Roger Gilbert. If you don't already know, I'm the publisher of Milling and Grain magazine. There's a copy here. Please take one away with you. Our magazine's been in print, servicing the milling industry since 1891. 1891, over 140 years. Obviously, it didn't start with feed. It started with flour, and flour still is a component of the magazine, but feed is the dominant subject today. Why are we here? We're supporting the industry, and through our good colleague Sebas van der Ende, we have been invited to host this meeting for Victam, which is Feed Milling Maximised. And Feed Milling Maximised is just focusing on some developments that are occurring in the industry. And we've been very privileged to have 4 experts in their field come along to address us today. So we're going to deal with those 4 in quick order. We'll start with our first speaker, who's Gunnar Hallman from Andritz. And as we all know, Andritz won the People's Prize for its innovation in the recent awards that we had for AFTAN. That's the Animal Feed and Technology and Nutrition Awards that were made on the first evening. So congratulations to Andritz. But Gunnar himself is going to address density matters, mastering expansion, control in aquafeeds and pet foods. I mean, we all know pet foods is becoming the thing, and pet investment in pet foods is global, not just in one region. So I'm very happy that we're covering this subject from not only the pet food, but also from aquafeed, which is also a very important aspect of feeding our world these days. Gunnar Hallman has 27 years of experience in the food and feed industries, including 5 years with Andritz. He holds a master's in engineering. His topic is process optimization and integrated solutions that improve efficiency, reliability, and long-term value in pet food and aquafeed production. So Gunnar, it's a pleasure to have you addressing us today, and the floor is yours.
Thank you very much, Roger. Pleasure to be here, and great that you have turned up here on the last day of the Victam. It is not easy. I mean, if you have been here all days, I mean, it has been a busy show. You are getting tired, and I can definitely feel on my voice it is getting tired, having been speaking here the last days. But it is great to have the opportunity to be here the last day. And today, as Roger mentioned, we'll talk about density in pet food, density in aquafeed. And the journey will take us, why is this important? Why should we even bother talking about density? And we'll learn a little bit about also how you can control it, because one thing is that it matters, but in a production environment, you also want to control things so that you are on top of it. I'll talk about the density in general, and then I'll present some of the solution. Roger, he mentioned our price. I will definitely get into that a little bit more in details since I have the opportunity here. A little bit about Andritz, just very, very briefly. If you do not know us, we are a global company with sites all around the world, and production sites, service sites, and sales sites. We at Andritz Feed and Biofuel are the small brother, because in total Andritz has 28,000 people employed, and in our small division we are around 1,000. We deliver machinery, equipment, solutions from single equipment up to our total plant operations. So let's dig into the subject of today and not spend a lot of time on Andritz. You can always reach out if you want to learn more. One thing is to get the basics right, and that is there's not one thing alone that determines your quality of your product. There's not one thing alone that influences things, but a number of things. This here is a simplified overview, and who have seen me before know that this slide is more or less always part of my presentation, because I think it is very important not just to focus on one thing. A lot of times we hear people, yeah, but we have an issue at the extruder because this and this and this. And then when we come out, we investigate it. What does it show is that the grinding is shit and influences the rest of the process. And due to that, everything counts, and you should never look isolated at a problem, but look at each single step along the way when you want to troubleshoot. So why do we bother talking about density? If we do not get our density right, it will cost money. It will influence on aqua feed, it will influence the feed conversion rate, it will influence the water stability. It will generate claims, and you do not want claims. It will generate problems. It will generate waste along the way. And also, if you do not do it right, it will actually cost you money in the drying process, because your dryer might over dry, or it might even be a case that your dryer is dimensioned in the wrong way because you are now doing products that are not fit for the dryer you have actually planned. And then it will cost you as well in terms of transport. If you have a density that is suddenly much too low, then your feed, your pet food, will have a much bigger volume than intended. That means it does not fit in the truck or does not fit in the bag anymore. And that definitely will cause you issues. I will now take you through a very, very brief introduction to density in aqua feed, and after that followed by pet food, and then go into details about how you can control your density in the process. Because why is it particularly important to control your density in aqua feed? You want to, of course, have a premium quality, but most important, you want to ensure that your feed has the right floating or sinking behavior. Because if you are aiming to produce a sinking fish feed and it floats instead, it will end as bird feed and not as fish feed. So therefore, you want to do that. Also, if your aqua feed sinks too quickly, it will end as waste down here at the bottom instead of in this area where the species you have in your aquaculture will eat it. It influences water stability as well, because if you get the density right, you have a very, very stable pellet in your environment. And then another thing, it is a little bit funny because oil addition makes a huge difference. And if you want to add the right amount of oil, and I will get to that in the next slide, you need to control your density. Because, for instance, if you look at salmon food, salmon feed starts as a floating pellet, but once the oil is added in the process, it actually sinks. And that is important to remember. So you need to have space in your pellet to actually accompany the oil that you add. While other products, for instance, shrimp feed, you do not add a lot of oil, and you need to control it so that it sinks down to the bottom so that the shrimps are eating it. Here, just an example of the oil presented. So if you have a product where you have a really higher oil content, then you need an expansion of your pellet of 40 to 50%, else there will be no room for that oil. So here the density is really important to control. Similar, vice versa, if you have only little oil, you do not want to expand your product with 40, 50% if you only add 10% of oil, because then there's too much space, there's too much air in the pellets, which means instead of sinking, they will end up floating instead. And that, as I mentioned before, will cost you money. When it comes to pet food, there are similar things that you need to control in your with the density. First of all is the texture, because the animals want something crunching. They want something to bite in. So if you do get a kibble that is very, very solid because you get the density wrong, you made a sinking fish feed density in a pet food, then the animals will not like it because it's too hard for them to break the kibble apart, get into it and eat it, break it up and eat it, also to digest it. So therefore, again, you need to get the density right in order to eat it properly. A thing that is also influenced is in pet food, we're talking a lot about fresh meat. And once you add fresh meat, your density changes. And that is something that you need to bear in mind, because when the density changes and when you add the fresh meat, the fresh meat has no binding capabilities. So you will have to add more starches to the product. And normally starches will expand the product in the extruder. But in this case here, it will not happen because the fresh meat will limit it. And here you can see a few examples of where we have no fresh meat, where the density is around 380, a great density for pet food. But then when you add 29 or 40%, depending on how you calculate the fresh meat content, your density will be around 470. So a much heavier, a much denser pellet. So that is something you need to consider when you produce, because it has an influence. It has also an influence on your packaging volume, because when a consumer in pet food buys a bag and then you have a product with a high meat content, then your bag needs to be smaller than a standard pet food. And you know it yourself, when you go out to the supermarket, you buy a bag of cornflakes, you open it and it's half empty. Then you think, oh God, it may be 500 grams, but they are cheating me. There's something wrong here. Similar with the people that buy pet food. The bags need to fit to the food that you deliver. So, what can you do to control the density? Traditional ways of doing that is in a single screw extruder, you adjust the speed, you adjust the die plates, you add more steam or less steam, you add more water. That is a very traditional way of controlling density, adding more water, making the product more dense. And that is also working, but remember, a lot of these things, you need to do that in the conditioner, and it takes some time before that mix is at the extruder head. So a lot can happen in between. So it takes time before you actually know, is this right or not? Which means in the meantime, you can generate a lot of waste. At the same time, by adding more water, what do you do then? That water needs to be removed again, so it will cost you on the drying. So therefore, you need to control the density where it matters. For instance, for pet food, Andritz has a system called the flex tax. There are other producers that have similar systems, so we are not alone on the market. You can also speak to other extruder manufacturers that have similar systems, but it is to control the density around the die, where we adjust the pressure by adjusting the opening of the venturi. Thereby we can put more or less pressure towards the die. If we add more pressure, the product will get lighter because it will expand more, and vice versa. And thereby we can completely control it, make fine adjustment to the density at the die. Similar goes for aquafeed, because there Andritz invented a system 25 years ago that was called expansion control system. That was a system that was patented. After the patent ran out about 6 years ago, a lot of our colleagues in the business have made their versions of the ECS. Due to that, and we'll get to that, we have now a new version on the market. But what you do is you pressurize the knife housing via an airlock. By doing that, you raise the cooking point, and that means the steam will not escape out of the pellet that easily. That means you will not have the same expansion, and thereby you can make a more dense pellet. So therefore, by putting pressure on, you raise the cooking point, and thereby you reduce expansion. As you can see here, you will reduce the expansion as you raise the cooking point. You can then also combine the ECS and the flex stacks, because that means you can handle products with low starch where you want an expansion in the beginning, but then with the ECS you regulate it again and decrease it. This ECS model has been in operation, as I say, more than 25 years and is installed on hundreds of extruders. But there were some flaws, and one of the main flaws was that it used quite a lot of compressed air. So we have here at the Victam, at our booth, we have a model of our new ECS, which reduces the air consumption with up to 80%. And what does that mean? An ECS normally, on an annual basis, will cost 30,000 euros in energy consumption for electric power. With the new system, we spent 6,000 to 10,000, so that's a huge saving there. And then you can say, whoa, Gunnar, you are spending 30,000 on compressed air to make a dense pellet. Yeah, we do, but it is still much, much cheaper than other ways, because, for instance, if you add extra water and you need to dry it, then you need to remember that the dryer accounts for 50 to 60% of the energy consumption in an aquafeed plant. And due to that extra drying, that will easily compensate for the additional electric power you need for the ECS. Roger mentioned it, we got the People's Prize for our invention there, which was fantastic, and we are very happy for that. And that's also, I could not, I need to adjust that slide here today and put that in. But with the new system, as I say, we gain a better quality, we have less air consumption, we have less maintenance. So all in all, it is a brilliant invention. Some final remarks, whoops, sorry. What happened there? Some final remarks. Density is not just something that you should see as a process parameter. Density matters. It's a product function, and it also has something to do with cost. If you do not control your density, you do not control your product. And if you do not measure your density, then you are not in control of it. So of course, you need to measure it all the time to make sure that you're on the right way. There are traditional ways to control the density in the process. I've mentioned a number of them, but there are then ways like the FlexTech, the ECS, and like I say, our colleagues around here on the Victam, they will have similar solutions. And just think about it, when you are looking at doing products, there are ways that can help you, that makes life much easier. And of course, we at Andritz would be more than happy to help you going forward. Thank you very much. If you want to know more, visit us at our booth 1001. Thank you.
Thank you, Gunnar. What an inspiring presentation. I think that there's a lot to take away in that presentation that is useful for us in our everyday work. And thank you for that, Gunnar. And congratulations once again on your award. Okay, we're moving to our second presentation. We're going to look at moisture. And we're going to look at why moisture control matters in the feed mill. And this is Neal of Hydronix. They're also on the exhibition floor, so please look out for them. But Neal, please. Neal gained his degree in electronic engineering from the University of Southampton in England. He spent 10 years developing and commissioning control systems for a major international food process system manufacturer. In 2007, he started working for Hydronix as a customer service and software development engineer before becoming its sales manager in 2011. Neal was promoted to sales director in January last year. Neal, welcome, and the floor is yours.
Thank you. Thank you, Roger. It's good to be here, and good to see quite a few of you, as Gunnar just said, who have made it through the week and have come to join us today. Thank you for your time, and I will try not to overrun too much. So, a little bit about Hydronix. We are a sensor manufacturer. We make a moisture sensor which is specific for use in the feed mill, in the agri-food industry, and that's our speciality. We're based in the UK, and we sell through resellers worldwide. So to start today, I'm going to explain about some of the concepts and ideas behind moisture measurement and moisture control, and why it's important in the process. Obviously, as grain is a natural product or natural material that comes from farms in natural environment, it varies continuously in moisture, because sometimes it'll rain before the harvest, sometimes it's sunny. This year it's just been all over the place. And that moisture is critical for the processing part. So where you're doing your operations in the feed mill, you're always need to be conscious of that moisture. By compensating and by controlling the moisture, you can then improve the plant efficiency. So by adding repeatable moisture control, you can get a higher yield, you can get more for your raw materials, you can get a higher quality, the correct quality of feed that you want to produce, with the correct densities and things like that as well. So all of this is important. And you can improve your profitability. You're getting more from your input raw material. You can reduce your waste by making correct material. Obviously, you're going to reduce the amount that is bad quality, is the wrong moisture, so it spoils. You can reduce or optimize your energy consumption by controlling dryers to make sure you're not over drying or under drying the material. And by doing all of this, you can also reduce your carbon footprint. Obviously, carbon is very closely related to the amount of energy being used in the process plant. So where can we measure moisture? So this is just an example of maybe a non-typical process plant. But it just highlights some of the stages where moisture is important and you can measure it. So, for example, where you get your raw materials, either from the farms or from other suppliers, you can measure as you're offloading to make sure that the correct quality is being delivered, to look out for wet material that needs to be handled or stored slightly differently. You can then measure in transfer points where you're moving material around and getting it into the silos. You can measure in the inlet and outlet of the dryers. Generally, we would look at that because then you can then use standard process control to actually control the dryer temperatures and the flow rates through the dryers. And then in storage, usually on the way into the storage or the way out. Then in the mill, in grinding processes, reduction processes, you can get the correct moisture and any conditioning steps just before that to make sure that you've got the right moisture going into the mill. Obviously, if you have the wrong moisture, it can make problems with the size of the output, and you need to get the correct durability and make sure that you're getting the correct out of your grinder. Then we have measurement in the mixer, so where you're adding water and or antimicrobials and other chemicals into the mixing process. You can measure whilst you're doing that to make sure you get the correct target moistures out of that. Then in the pellet mill, so where you're actually in your pellet mill or extruder, you can measure on conditioning steps again, any input, and lastly, in the packaging, so as a final quality control, it's important to have that record of what the moisture was in the process so that if there's a problem, it can be picked up and notified. So different methods of measuring moisture. So traditionally, people would go to a process plant, they'd take a sample of the material from the plant, they would then take that to the laboratory and test it. Sometimes they don't even use a laboratory. More often on farms, you get the small handheld testers. So these are they're good devices, but you're looking at a very small amount of material from a large volume of process. Then you have online measurement, which can be used for online feedback control. There's a few different options here at different price and pain points. You have capacitance-based sensors. There is older analog microwave sensors. There are near-infrared sensors that obviously also give you many other measurements as well as the moisture. And then there's the digital microwave measurement, which is what we use. So why do you want to measure online? So one of the things you need to get from your measurement is a full knowledge of all the moisture going through your process plant, because then you can react to it, you can make changes to your process. And you want an accurate representation of the moisture that's in that material so that you can properly control it, so get a precise output. So just to explain a little bit about why offline is not quite the best method for process control measurement. If we were to take 3 points, so we take samples from the process that, as we said, was varying, we then take 3 samples from that process, we can see that this would give you an average moisture, which is up at this 24% level. What we actually have, if we take the whole of that variation into account, is it should be down here. So it's missing by maybe 1 or 2%. Obviously just an indication, but hopefully it gets the idea across. So we want to measure online. As I said, there's a few different options. So NIR and infrared is very well used. It's very, very good. It is higher in ownership costs, but does give you the extra protein and fat contents that you do need sometimes. It does tend to get affected by some of the process conditions changing. So it can be affected obviously by dust. It's a visual light-based system, and it can be affected by the colour of the materials changing. So if your dryer changes the colour of your pellet, for example, it may change the effect on the infrared. And there's also an effect from temperature. So older types of the RF type-based measurements, the resistive, capacitive, and microwave analog, do tend to still be affected by temperature changes. They're also affected a bit by salt changes and conductivity changes. And this can come from different source materials being handled in different ways. For example, if a farmer uses a different fertilizer on their crops, then that can be absorbed into the material and affect the conductivity of the material, which will then affect these measurements. They are not so affected by dust because it's an RF-based electromagnetic measurement, and again, not affected by colour. But they're a non-linear measurement, so they're a little bit more complicated to work with from a process control point of view. These are penetrative technologies, so they do measure into the material flow. The NIR tends to be just a surface measurement. Then we have the digital microwave technique. So this has a very low ownership cost, because once you've installed it and commissioned it and calibrated it, the ongoing maintenance is minimal. There's generally very, very low wear. There's no need to recalibrate unless the product changes. They're not affected by temperature. The salt doesn't change them. Dust and colour are not an effect. But they must be in contact with the flowing materials. So there is a need to get the face of the sensor in contact with the material. This is the same for the other non-visual measurements as well. So what can we get by controlling the moisture? So I've just got a bit of an example of one of the concepts that we've learnt over the years. So we had a customer that was having quite a bit of problems with their dryer control. They had to basically, because they only had about 1% accuracy on their measurement because they were taking offline samples, and that's quite good for laboratory-based systems. They were drying from 20% input moisture in the grain dryer down to 14%. But because of that 1% accuracy, they had to target 13%. So they needed to remove at least 7% moisture to make sure that obviously if the variation was maximal, it was still under that required 14%. So we helped them, we installed a sensor. We would say that the online sensors, generally you can get to about 0.5% accuracy in what you can actually show from the laboratory process. A lot of the sensors are more accurate than that, or more precise than that. The problem is trying to prove that with a laboratory-based technique. You're taking small samples from a big flow, so you're always going to get some fluctuation. But we say 0.5% is a good target to bear in mind, a good accuracy or precision. So that means that you can target 13.5% then, which means you're only reducing the moisture by 6.5%. So this means that your energy required by that dryer that's drying that material goes from nearly 46 kilowatt hours per tonne down to 42.5. So that's an energy reduction of about 7% in your energy costs. And as was already explained, it's one of the bigger costs of the plant. So there was other good outcomes from this as well. So by doing that dryer control, getting that extra 0.5%, you also on the, it was a 16-tonne dryer, so the customer was actually making 80 kilograms of extra yield because you're having that correct moisture rather than over drying it. So that lower energy cost was, in the UK, it was £15, £16, so about the same in euros. And it reduced their emissions by 10 kilograms CO2 equivalent per 16-tonne batch, which obviously is good for the environment. So one of the things to bear in mind when you're selecting different sensors to use is how you connect them to your plant. It's very important to get good data into your plant. You can then record it, you can parameterize it, you can use it for the control, and you can use it for ongoing troubleshooting and also any requirements from governments and things for reporting. So sensors can be connected to user interfaces. They can then, well, it's very important to have some sort of interface, whether that's through direct connection to the sensor or through the control system. Sensors are best connected to the control system because then you use them effectively rather than having an operator step which is then continually going back and forth. Modern systems can then connect to networks, so industrial networks, which can then be used with Wi-Fi, for example, to then have calibration, commissioning, and interfaces on tablets and on phones. And lastly, these systems can then do database transfers, so you can gather data from the plant to then compare with other data you can collect from your site and your process to then make decisions on enterprise or resource planning, or even just sort of information systems that can then be used to do after report and monitor the things. So in conclusion, just to wrap up, why do you want to measure moisture? It's to react to the changes in good time, which gives you benefits because you're controlling the moisture, that you can then reduce your energy, your cost, and help that environmental impact. Where to measure moisture? There's a lot of steps you can measure moisture and many locations, as we said. How do you measure moisture? So you can do online is what we would suggest is the best. And then connectivity, it's good to have that connectivity for your sensors. So we're here at the show. We're at booth number 6043 over in this hall. And please feel free to come and see us. And lastly, thank you.
Thank you, Neal. Thank you very much, Neal. Just drop your microphone. Okay, thank you very much. And I think there's a theme developing here. And one of the things Neal brought to our attention was our carbon footprint. And I think all our feed mills have to begin establishing what exactly their carbon footprint is in a way of proving further down the line that the products that are finally produced for the supermarket are making a difference to the environment and to the way the industry is addressing its carbon. But the theme that I'm seeing is that we've dealt with density, we've dealt with moisture, and now we come to odor. These are all sorts of things that we might not pay much attention to, but have big impacts. And this third one is going to have a huge impact on our industry as we go forward, as maybe urban areas expand and we become more part of communities around the world. And I'm pleased to say that I have Merijn Appelman from Aerox to address us now. He's going to look at proven solutions for industrial odor reduction for the animal feed, aquafeed and pet food industries. Merijn is a sales manager with Aerox, a company specializing in industrial odor control solutions using advanced cold plasma technology. In his role, he focuses on driving international sales, developing strategic partnerships, and helping clients across industries implement sustainable odor abatement systems. With a strong background in odor management and process technology, he plays a key role in delivering tailored solutions that meet environmental regulation and improve air quality worldwide. Looking forward to your presentation. Thank you.
Okay, thank you very much for that wonderful introduction. So I will explain something about odor control, our odor control system. But first, I would also like to introduce you into the world of odors and odor measurements. So Aerox is a company doing odor control using the cold plasma technology. We are based in the Netherlands and we provide only one technology, and that is mainly specialized in odor control for the animal feed, pet food, aqua feed and the oilseed industry. So by now we have about 350 units worldwide in all kinds of different plants, all parts of the world. Before I will explain something about the odor control system, I would like to introduce you to the world of odors and how odors are being measured. So odor measurements are done with the human nose and by using an olfactometer. So the science behind it it's real science. So what you do is using the olfactometer and you dilute a sample that has been taken from the chimney of the odor source. This sample is connected to the olfactometer and that is diluted before it will be presented to the odor panel. First of all, the samples are diluted that much that it cannot be distinguished from odor-free air. And each step, the dilution will get less and less, and therefore the sample will be, the odor sample will be stronger and stronger, until a certain moment that the diluted sample can be distinguished from the clean air. So if this happens at, for example, 5,000 dilutions, then the odor concentration will be 5,000 odor units. So that is the definition that we use for odor measurements. So the human nose is not very accurate, but by using this method, we can make a rather accurate measurement, because we don't only use one person, as you can see here, but we use at least 4, 5, or 6 persons. So we get a big group of people, a big group of data, and we get a nice average. So during the odor measurement, we cannot use everyone. So all the panel members that are used for an official odor measurement are more or less calibrated. And this calibration takes place using N-butanol. This is a certain substance, and all the people have to be able to smell the butanol between a certain range, and if they cannot join. So we are looking for the odor laboratory for average noses. So you cannot smell too good, but also not too bad. So that is the introduction for the odor measurements. Now, for the feed industry, there are many different sources. Depending on the type of feed you produce, for example, if you produce animal feed, you normally have a pelleting line. So then you have the pelletizer, dryer, cooler. But in the aqua feed, as you can see here, you do that using extrusion, and therefore we have the exhaust there from the extruder. This is a very big source, because the odor concentration is very high coming from the extruder. You have the dryer, and last but not least, you have the cooler, which is also a significant odor source. So for the extruder, you can see that you have normally a low volume flow rate, but a high odor concentration, which makes it a significant source. For the dryer, normally, depending on the dryer a bit, whether you have a vertical or horizontal dryer, but normally the volume flow rate is quite high, also a high odor concentration, so this is normally the highest odor load coming from a pet food or aquafeed factory. And then last, the dryer. So you can see that the volume flow rate is quite high, but the odor concentration is quite low, because there's only a part of cooling, so not a lot of odorous components come out of the exhaust there. So here you can see some typical values. Maybe if you are really into odor measurements, if you are environmental manager of a feed plant, this could be interesting. For now, I just skip the details. If you want to hear more about it, you can always visit our booth. These are typical results for odor emissions of animal feed plants. It's a little bit different than for aquafeed and pet food plants, because in aquafeed and pet food, the odor concentrations are normally much higher than for animal feed plants. So why is odor control needed? Normally, there are 3 reasons why odor control is needed. First of all, if there are complaints from neighbors, then that could be a direct reason for the feed factories to reduce the odors and to contact an odor abatement company to reduce the odors. Second of all, legislation. In many countries, there are odor legislations, not only in Western Europe, also in Latin America, in Asia, there are also very strict odor regulations where the companies have to comply to. Despite the fact whether there are complaints, yes or no, they just have to comply to the odor regulations. So those are the two most important reasons. Third reason can be that it's just because the company says, okay, we want to achieve a very sustainable, we want to be a very sustainable company, and we want to do this for all of our plants the same. So we want, whether we have a plant in Asia or maybe in Africa or Latin America, we want to have odor control for all of our plants. As you can see here, this is an example of a dispersion model. After odor measurements have been done, we can make a dispersion model, and this is done by creating circles around the company. And you can see that, for example, the red line is a high odor load area. The green one is a lower odor load area, and the blue one is the lowest. So regulation can be, for example, that the green line, the medium one, that within this line there cannot be houses. So in this case, you can see that there are a lot of houses over here and also over here. So in this case, the company needs odor reduction to make the green line smaller. So an odor measuring company can exactly calculate how much odor reduction is needed. And of course, an odor abatement technology can make sure that this odor reduction is achieved. So in this case, we applied 80% odor reduction for this company using the Aerox injector. And you can see the green line is even completely disappeared. So 80% of odor reduction was more than enough to help this company. So this was a little bit about odor measurements and why odor control is needed. Now I will explain more about the product of the Aerox injector and the technology that we use. So we are mainly active in the pet food, aqua feed, animal feed industry, also in the oil seed. Those are the biggest focus industries of us. Some others are also mentioned here. Now let's see if the movie starts.
De aire de hasta 90.000 metros cúbicos por hora. Esto lo logra haciendo pasar aire ambiente por un filtro de 3 etapas. El aire purificado ingresa a una serie de módulos de plasma frío. Así como las tormentas eléctricas.
I'm sorry, I will just skip the movie because the explanation is in Spanish. It's a different movie. I will just explain it here on the pictures. So the technology is that we take fresh air with the fan. The fresh air is then filtered into a 3-stage filter, and after that it is injected, or it goes into the injector cabinet. In the injector cabinet we have the plasma modules. So the plasma modules, that is actually the heart of the system. So that is where everything happens. So in the plasma, by blowing air through the plasma modules, we create oxygen radicals. And those oxygen radicals, they are injected into the process duct. And those oxygen radicals, they are immediately reacting with the odorous components, the organic odorous components of the process air, and resulting in oxidized or oxidized organic components. So they break down actually the organic components by which we achieve a certain odor reduction. How much odor reduction we can achieve for a specific factory or a specific recipe or a specific process, that is different. So that's why we can do several tests. We can do, for example, a suitcase test. This is a very small test. We can do it very quickly in half a day, and it is more like an indication. It is more a feasibility check. Or we can do an official pilot test. That's here on the right. And with this pilot test, this will be a real official test. We also invite an odor measuring company. And this odor measuring company, they will take samples before our pilot test and also after the pilot test. The odor samples will then be analyzed in the odor laboratory, and, well, the final result will indicate the amount of odor reduction that we can achieve. For example, they measure 10,000 before, 1,000 after, then we achieve a 90% of odor reduction. We can do that at different settings or different recipes of the factory. By doing it at different settings, we can immediately see how much capacity we need for the full-scale Aerox injector. So here you see some pictures of the suitcase test done in an office. And this is the pilot test, including the sampling of the pilot test and the evaluation using, again, the olfactometer, which I explained in the beginning. So the graph here, you can see some typical results from a pilot test at 10xg capacity. The 10xg stands for quite a low capacity of the Aerox injector. This is our commercial term for the capacity. So you can see that there we achieved 40% odor reduction with a 20xg, so double the capacity. We had about 80%, and then you see that the line is going a little bit flat. So with 40xg, again at double capacity, we achieved approximately 90% of odor reduction. So depending on the odor load that the company needs, or the amount of odor reduction that the company needs, we can now choose the right capacity of the Aerox injector. So this is a very useful test that we can do. So with the different capacities of the Aerox injector, we can treat certain airflows. Nowadays, because of the increasing research that we do and also getting more and more powerful plasma modules, we can nowadays treat approximately 300,000 cubic meters per hour with the biggest unit. Of course, also the small factories, if you have a small processing line in the pet food or the animal feed, we can also treat approximately 5,000 cubic meters per hour. There's a big difference between the beginning and the end, what we can treat. So from 5 to 15,000 cubic meters per hour with a 5xg, there is a big difference because it all depends on the odor concentration. For example, a 5xg in the animal feed, we can treat 15,000 cubic meters per hour. But for the aqua feed industry, where we have a high odor concentration, we can treat with a 5xg maybe 5,000 cubic meters per hour. So I don't know whether you already visited our stand, but then this picture sounds familiar. This is a picture of an animal feed line here in the Netherlands. We treat about 100,000 cubic meters per hour, coming from 6 pelleting lines, and we achieve approximately 90% of odor reduction, with which the company complies to the odor regulations. I will just go quickly through the case stories, since almost running out of time. Aquafeed factory in Chile. They installed now 1 unit on the flash off, so the extruders, and we had a 90%, 96% of odor reduction on a flow of approximately 10,000 cubic meters per hour. This is, we are treating the flash off of 4 extruders here. This was an aquafeed factory in Japan, and the problem with this case was that they used to have a scrubber, but they used a lot of chemicals for the scrubber, and therefore they spent a lot of money of getting rid of the chemicals, but it has to go to a wastewater treatment plant, had to go by truck there, so a lot of problems, and the odor reduction was about 70%. So at the end, we did a test, and we achieved approximately 70% odor reduction during the test, so they were very satisfied. At the full-scale validation test, we even became up to 90% at some recipes of odor reduction. So the last one is a pet food factory in the United States. Normally this company always used incinerators or RTOs to get rid of the most of the odors. Nowadays the gas prices are very high, so they were looking for an alternative, and that's why they chose also for the cold plasma technology. So we supplied in total 16 units to 2 different factories, treating all of the exhaust air from the flash-off, dryer, and the coolers of these factories. So thank you very much for listening. Don't know whether there are any questions.
Merijn, thank you very much for that enlightening presentation. I think we've all learned a little bit of detail about the odours that we produce, but also how to control them. So thank you very much for that. If there are any questions, just pop your hand up and I can get your microphone to you. But for now, I'd like to move on to our final speaker, who is coming to us from Finland, from Neova Oy. It's a company in Finland, and Sergei Kaplunovich. Yes, thank you. Sergei Kaplunovich. Yes. Okay, is going to address us on optimal dosing window in animal nutrition. And Sergei is the technical sales and marketing manager for Nova Agro. With over 11 years of experience in animal nutrition, he specializes in livestock nutrition and genetics, focusing on pure natural feed ingredients based on Finnish peat. I'm intrigued by that, with a strong emphasis on sustainability and performance. He works across Europe, Latin America, and Asia. Sergei, the floor is yours. There's a microphone there.
Thanks very much. I was so happy to discover that the other lecturers didn't speak for 20 minutes, which means I got plenty of time. So I'm coming from, my name is Sergei Kaplunovich. It's always a challenge to pronounce my surname, I know this. Coming from Georgia, and in Georgia we have such an expression. It's difficult to explain to any foreigner that for a Georgian male, one bottle of pure Georgian red wine is just enough. 2 bottles of pure Georgian red wine is too much, but 3 bottles of pure Georgian red wine is too little. Bring more. A small question before I start, just to adjust my presentation. May I please ask to raise a hand people who are also related to animal nutrition and feed formulation and not only to mechanization? Oh, great, fabulous. So I'm going to speak for the 3 of you. Perfect. So, just as I told you about wine, something is too little, something is too much. The same story comes with the optimal dosing window in animal nutrition. Here's the program, how we're going to move forward with this. First, I will speak on one of the materials which is closer to me. So, assuming I'm coming from Finland and we have plenty of peat over there, I would take peat as an example. Then we shall have a brief overview on the impact of non-linear effect. So it's not the more you add, the better results you're getting, but you should be very precise on that. Then we shall see how it optimizes performance. We shall look into microbiota and health briefly, what changes it brings, and then the environmental effect. So, the versatile peat matrix. So, whenever speaking about peat, it sounds like something organic coming from natural sources, and indeed, so what peat is, we got products, fossils like leonidite, sapropel, which are actually rocks, and they are very high on specific humic acids predominantly. On the other hand, one of the drawbacks is the heavy metal contained of them, and their bioactivity. So what we normally do, so when I was speaking about peat, this is something considered pretty young. In our sphere, it's only 100 years old, up to 10,000 years old. So way younger and way more active. What it consists of? It's actually the plants who are dying, then degrading, so all of this material, it becomes bioactive, bioavailable. The way we do this, just imagine the territory of Finland, where we take 300 samples, 300 spots, where we analyze the peat for, first of all, being compliant with EU regulations on heavy metal contamination, compliant with all EU regulations on hazardous substances, so we would be sure that it's a natural, very safe product. And the second thing would be that we have specific claims on the amounts of humic acids, organic acids, folic acids, so we should be within them. That's why we test 300 and we take only 3 to 4 spots. The product is renewable, so every next year we change the spot, and it takes us just 1 year to get 7 millimeters on top of it, so it's restorable, recoverable by nature. Of course, if you look at the whole map of the Earth, you will see that products like peat can be found in various areas, so some in China, some in the US, some in Canada. What makes the Finnish peat specific? To be honest, it has nothing to do with any specific plants that it's made of, but rather about the quality controls that we're taking over here. This is the thing where we're proud. So whenever being asked what's the difference, you just show them the levels, the regulations, the requirements, and then you're on the safe side, and that's how we've been in this regards. Of course, there would be a disaster to ask somebody to import peat from a very distant part of the world. So that's why we needed to make an extract in liquid form, which is preferable for broilers, and in dry form, which is preferable for feed millers and premix factories around the globe. So we make an extract which is rich on organic, humic, and folic substances. It can be easily introduced and mixed in mixes. And we got strong scientific evidence, so we cooperate with various universities in the EU, in Southeast Asia, in Central Asia as for now, and running some trials together with institutions in Latin Americas. How it works? Let's say this is the intestine. So we got villi, through which all the essential substances are getting through. Amino acids, fatty acids, macrominerals, trace minerals, vitamins, they all need to get through. So what actually the product does, this extract does, it creates an additional layer on top of it, which has proven to let the positive and beneficial substances through, and at the same time to keep the pathogenic bacteria away. They stay in the lumen and then they go to the manure. This goes for gut protection. We are aware and we have pretty impressive results on antioxidant action. Why it matters for us? Because the end farmers are happy. So they understand that the more energy is stored within the animal and not being aimed at not being challenged by pathogens and immunity questions and so on, then the better growth, more milk, better eggs, more pork meat, more chicken meat. For nutrient chelation, while walking here around, especially at VIV section, there were pretty many companies that are making good money on chelated trace minerals, adding organic substance to zinc, to copper, to iron. And the bioavailability is way higher. That's why you pay tenfold and you get better bioavailability. So peat extracts are famous with essential nutrient chelation, so it just makes it automatically within the gut. Nobody needs to pay extra. And that's another reason why feed millers all over the world prioritize this way of chelation. The ones who go away about this. Fiber-like matrix, it supports gut morphology in terms it improves the peristaltics. So, impact of non-linearity. There will be two, uncaring to talk only about how perfect our product is and other products perform worse than ours. Therefore, so here I've taken quite several producers of alike substances. So I took warm composting, it was warm leachate, sodium humate, fulvic acids, different humic substances composition, and pure humic acids in feed. And everywhere, according to literature, there is an optimal dosage of them, which guarantees the best results. So even in somewhere they say if you add in layers more humic acid, you will get higher egg production, but the thickness of the shell would be compromised, and vice versa. So it depends on what we need. And it works with any species. If we can go to our latest research, I would first like to focus your attention on this part of the chart. Here's exactly what we see. 0.15%. So it's 1.5 kilo of the extract per 1,000 kilograms. Against 3 kilograms, so double dose difference. Here's what we see. Even if we add more, the daily gain per day on broilers, it was just the same, so why paying twice, right? And on the other hand, we increase the dry matter intake, we increase the feed intake, which brings to worse conversion ratio. You pay less and you get better conversion. Look at the mortality. This has been a farm in the Netherlands where all the medications were completely prohibited, so only anti-coccidiotic program was acting. As for the rest, so no antibiotics, no medications were allowed. So in the control group, the mortality level was pretty high. If we had 3 kilos, then it was better. But if we look at the minimal concentration, which is within the optimal window, then we're getting to only 4.4. It's half of this. So that's how crucial it becomes. Same story, so just to be sure, we tried on the piglets the same. Our last trial has shown that, the conversion ratio gets better and the daily gain gets better and the mortality is decreased significantly. So there is some big line here, the European production efficiency factor, and this gross profit per bird in euros, which I will talk about in a couple of slides. As for this one, so here's the formula of it. How much meat the broiler is gaining, how many of them survives until the end of the cycle, and we divide it by the feed conversion ratio. So what we were proud of that it was changing significantly, you see here, because of the factors that you saw at this slide. As for gross profit per bird, it looks like only 3 euro cents difference. On the other hand, we multiply it by 2 million broilers that they have on farms in the countries we're servicing, and then the numbers are becoming significant. What could they afford? Better machinery that the previous lecturers were talking about, maybe That's where this money could be invested. Talking about microbiota and health, this is a very good one because it provokes a question. So this is the beneficial bacteria, the good guys, and this is the bad guys, Campylobacter. So, and we see that if we add more of the product, then there is a huge reduction in the population of those negative bacteria. On the other hand, if we add more of the products, we get more lively bacteria. So the question appears, so it is linear. So how come you're speaking about some optimal windows? You add more and you get better results. Then appears the question, so why at this chart? We added more, but the results were worse than that. And then I go back to this particular picture again. You remember I told you about this additional layer protecting the gut from hazardous things and pathogens. When you are making this layer too thick, not this thick, but this thick, let's say, then the positive things also have troubles with getting into the bloodstream, so the absorption is worse, and they simply stay in the lumen of the intestine. And another thing is, about nutrient chelation, let me be honest on this. If we add too much of this, it starts chelating macrominerals like phosphorus and calcium. And these molecules are very big. They simply don't let the smaller molecules to get into the organism, to get properly into the bloodstream. So that's why this is no linear as well. So creates gut environment good for positive microbiota and decreases negative microbes. As for environment, so according to our calculation, from 452 and 400 to 500 kilograms of CO2 equivalent is the carbon footprint for producing 1 ton of the product. With these dosages of 0.15%, when we dial it into our recipe, this absolute minimum, we shrink the carbon footprint per unit of meat produced eventually. So, the key message of this presentation has been that we need to seek the performance window and not bluntly go for the maximum. A couple of words about the company, because the last thing usually a speaker says usually stays in memory better. So, Neova Agro is a state-owned company. Half of the company belongs to the state of Finland. We've been working with peat for the last 80 years. So, you see the average turnover, 800 people work for us nowadays. We produce everything that's connected to peat. It's for animal feed products. It's the extracts. We also got soil conditioners, biostimulants. So with 80 years of research, we combine these local organic materials with modern technologies, which the others are talking about. So and all products are backed by scientific literature and trials. Thanks very much for your attention. I've been too quick, just the same way as everybody else. 20 minutes, all right. I fit into 16.
Thank you very much, Merijn. I really...
Thank you.
Thank you very much, Merijn. I was intrigued with that. I mean, it's an ingredient that is not high on everybody's radar, but maybe we should be looking more closely at these types of products. Thank you very much. And some of this research goes back considerable time. I think all our presentations this morning have been focused on one thing, and that's the reduction of energy and our carbon footprint. And I think these are innovative methods of bringing that about. And I think it's great to have had 4 speakers address that subject in their own way. If we have any discussion points, I'm happy to share the microphone, any questions that you might have. But I am aware that the show rolls on. It's into the last few hours, and our speakers, I'm sure, will want to get back to their stands. And by mentioning that, please make sure you pass by them. Thank them very much for their presentation today, and enjoy the rest of the show if there's no comment or question. Any comment or question? No? I thought there might not be. I think there's a lot to take in. But thank you very much for attending. We appreciate you being here. It's been videoed, so you can catch up through our magazine or through our website if you want to re-watch some of the presentations. But thank you very much for attending this morning.